Do you like books? I mean, really, really like books? Then you're in the right place. Each week, your host, Sam Hankin, interviews the best of today's top-selling authors and the up-and-coming superstars of modern literature. This is The Avid Reader. Here is your host, Sam Hankin.
Hi, everyone. Thanks again for joining us here on The Avid Reader today. Our guest is Walter Isaacson, author of The Codebreaker, Jennifer Doudna, Gene Editing, and the Future of the Human Race, published in March by Simon & Schuster. You know, sometimes I wonder at my bookstore, Wellington Square Bookshop, I think most of you, my listeners, know that Walter was editor of Time, that he was president of CEO of CNN, that he was head of the Aspen Institute, one of the most 100 influential persons in the world. And in my bookstore, shelving, I'm always shelving Leonardo, Benjamin Franklin, Einstein, Steve Jobs, the innovators, Henry Kissinger, and their beautiful Simon & Schuster bindings, which is important to me. And now the new one, the Codebreaker, is in the front windows and it's on the front table and selling like hotcakes. And I always wonder, why is Walter so famous and well-known and has so prestigious? And I didn't know why. And then I looked at Wikipedia and I realized I was born May 21st, 1952, and Walter was born May 20th, 1952. And it's because of his extra experience in that one day. If only I had had that one day, I could have been his peer. So that's my excuse for why I haven't achieved the same things. So today, we'll be talking a little bit or a lot about CRISPR, which is an acronym that will save us a lot of time today. So RNA was at one time kind of like the red-headed stepchild of DNA, what was vaunted. Now it is very well the scissors that may snip the human race fast forward, almost perhaps in a self-evolutionary way. The book is about Jennifer Doudna and ancillarily Emmanuel Charpentier. The beauty in nature and discourse, by chance, a copy of the Double Helix by Watson is found almost accidentally on her bed by Jennifer. And over half a century after Walter and I have read the book as well, we fast forward to the Nobel Prize, which is how the book begins. So you've said, Walter, many times in the past that nature is beautiful. And I wonder if I could read a very short quote from Emerson for you.
Yeah, fine, thank you.
And it is, Emerson says that nature is beautiful because it is alive, moving, reproductive. In nature, we observe growth and development in living things, contrasted with the static or deteriorating state of the vast majority of that which is man-made. Nothing is quite beautiful alone. Nothing is but beautiful in its whole. And I thought we would begin by moving deductively rather than inductively from that general statement. We know that the DNA code is the language of life, GCAT, guanine, cytosine, adenine, and thymine. How can four letters be so important for the human race?
Well, about 4 billion years ago, in the stew of chemicals that was on this planet, four molecules kind of bumped together and they form an RNA, which we now know is the beginning of life on the planet. And as you said, DNA is the famous sibling. This is the step sibling, the one that's not quite as famous, but it turns out to be there for the origins of life on this planet. Of course, it's a messenger that tells our cells to build a little spike protein when we make it into a vaccine against COVID. And it becomes a scissors when we use it as a guide with an enzyme to cut our DNA. And so these four letters of the genetic code, we have 3 billion pairs of them in our genome. So that can encode all the 30,000 genes and all the things that help build every cell in our body. And it's actually more efficient than the digital code that we use in our computers, which only has zeros and ones. This one has four letters. And Jennifer Doudna, the hero of my book, was able to discover how RNA can replicate itself, how even with just this tiny coding, it can then pull itself and copy itself, which is why it's the beginning of life on this planet. She also discovered how to make it into a guide so that you can cut our own DNA. And other scientists have worked with her discoveries to make it into a vaccine.
Well, talking about Jennifer, and a word you use quite often is curiosity. And I thought about it again as I'm shelving my books. And whether it's Leonardo or Einstein or Steve Jobs, who I kind of wish was still around because I think Apple would be in a different place with him still here. So what is it about curiosity that leads to all of these advances for us?
Well, you talk about Emerson saying nature is beautiful, and Poincaré, the great physicist in the early 20th century, he said the scientist studies nature not because it's useful, but because it's beautiful, because it delights. And we all have a natural curiosity. In the margins of his notebooks, Leonardo da Vinci writes things like, "Why is the sky blue?" Now, you and I remember being kids and we marvel at, a blue sky, but we outgrow our wonder years. We quit asking, why is the sky blue? Well, Einstein in his notebooks also asked, why is the sky blue? So does Jennifer Doudna growing up in Hawaii. All of them try to figure out the spiral forms, like in seashells or water passing a flowing water passing a rock. These are curiosities about basic things we observe every day. And Einstein once said, I'm not smarter than other scientists, I just happen to be more curious. Now, he was wrong about that. He was smarter than other scientists, but he was definitely more curious. And the great thing about curiosity is you and I can do it. I mean, we're never going to be Einstein in understanding the math of general relativity, but we can be just as curious as he was.
And it's interesting that you make all of this so accessible. First I thought this book's going to be really tough for me to get through. And then I realized it was so accessible. And a lot of it is because of the metaphors. And they make such a difference in being able to read this book, except for, especially for the general public. But one of the things I remember you talking about at the Harvard bookstore talk, and I can't pronounce the gentleman's last name. Is it Lu?
David Liu, yeah, he's a Harvard geneticist, yeah.
And that was a great talk. And one of the things he talked about, and this is another metaphor, at least to me, when he's talking about Alzheimer's disease or progeria, he says basically it's just a 1 or 2 letter switch. And I think that's something that the general public wouldn't understand, because it doesn't seem like, how is it possible that there's just this one of the 4 letters that switches?
Well, there are certain syndromes and disabilities and genetic defects that are single letter mutations. Alzheimer's happens to be more complicated, but sickle cell we were talking about is simply a switch from an A to a T in the 3 billion pairs of letters we have in our genome. And just with that single switch, you can end up producing blood cells that are sickled. Likewise, there's simple single gene mutations that for 7,000, I think, diseases, some are very prevalent, such as cystic fibrosis or Tay-Sachs or muscular dystrophy or Huntington's disease. So these simple genetic mutations we're already fixing using this gene editing tool known as CRISPR.
When you were talking at Harvard, he very conveniently for the audience went through a set of 4 questions and how you would respond morally, ethically to those 4 questions. And when we talked just now about progeria and Alzheimer's, you said unequivocally, yes, you have no problem with them being used to solve these problems, these diseases. But one was fascinating to me that I had never heard was about, and he said it, but you wrote about it, was that cross-country skier from Finland. Maybe you could tell us a little bit about that and how that leads into whether you believe enhancement is something we should look toward.
Right. When Jennifer Doudna, Manuel Charpentier, and the heroes of this book discovered how you can easily make genetic edits, Jennifer had a nightmare. And the nightmare was that somebody wanted to understand it. And she goes in the room and the person looks up and it's Hitler. And so she realizes that if you start using these things for, enhancement, you can cross a line ethically, especially if you're trying to create a master race or master children for that matter, even if it's just done by individuals to say, I want my kids to be enhanced. and we create a genetic elite, like in Brave New World or the movie Gattaca. And we talked a moment ago about changing the single letter that causes sickle cell, and that just means you get sickled cells that don't carry enough oxygen. Well, there are other genetic mutations that exist in the human species. They're very, very rare, but they do the opposite. They create blood cells that carry more oxygen. And when this cross-country skier was performing miraculously, they thought maybe he was doping, that his oxygen levels were so high in his blood. They almost disqualified him. But then they discovered that he and a lot of other cross-country skiers and marathoners have a natural mutation that's very rare, but it produces blood cells that carry a lot more oxygen. Well, if that's the case, it wouldn't be that hard to edit our own blood cells or those of our children if we want to produce marathon runners and track stars and cross-country skiers in our kids, or maybe just want to have a healthier life where we don't get as winded and we don't get as tired and we have more endurance. So there's a blurry line between fixing genetic problems like sickle cell and creating genetic enhancements like blood that carries more oxygen. And so I'm going to hurt the sales of the book by revealing this. I don't have a last chapter in which here's the 7 easy answers. But where I try to go with Jennifer Doudna, her colleagues, religious leaders, and philosophers in a section of this book and say, let's take certain cases. Well, clearly we'd fix sickle cell, but will we do it to make enhanced blood cells for our kids? Clearly I would do it to fix Alzheimer's, but would I do it to create memory cells in myself or my children that are better than average memory cells, and which would be a component even maybe of boosting their intelligence? And so the blurry line between treating a disease and enhancing a human is one we have to figure out, do we want to cross that line?
Yeah, and I have to say it, blurry lines kind of scare me. And, when I went to law school, they always talked about this slippery slope. And what you say is, it is a slippery slope. It's dangerous. So let's take it very slowly. But then I thought, suppose you're in Aspen and you go up to the Highland Park Bowl. Well, it's a double diamond. And if you try it and it's slippery, you'll get to the bottom. But the question is, how do you get to the bottom? Right. And you know how the human race is. We're not that smart in some ways or ready to do these things. Aren't you scared?
Well, all slopes are slippery. And so the question is, how do you get footholds that, are solid enough? How do you have moral steps you can take and feel comfortable with? And one way to do it is slowly, cautiously, and preferably hand in hand, meaning as a society, we all have to figure out what do we consider good and what do we shame. And people say, well, it'll be hard to make rules and regulations. No, we make rules and regulations even about what vaccines you can use and how you can use your vaccines. And we also even have a sense of social shaming, which kind of surprised me and pleased me when it came to the current vaccines that rolled out. I thought rich people were going to rush like crazy and make donations to hospitals and cut in line, and brag about it. It actually became a bit of a matter of shame if you didn't wait your turn for the vaccine. So we can try to control our new technologies by saying we need FDA approval, we need to have international cooperation with all the regulatory agencies. And as a society, we have to say what's good, what isn't, whether it's doping our kids so they be better athletes or gene editing our kids so they be better athletes.
What about the Chinese scientist that you spoke of, who's now, I guess he's still in jail, right?
Right. Well, people say, well, won't China do it? Yeah. In China, the embryos of what became 2 twin girls were edited by this sort of rogue science who'd been to Jennifer Doudna's seminar, some of them. Wow. Even took a selfie with Jennifer that's in my book. And he was a young scientist, not a great researcher, but he was able to edit the embryos of twin girls so that he didn't have the receptor for HIV, the virus that causes AIDS. Well, he thought that would be a great thing. But China and the US and Europe and Britain were all part of a consortium saying, let's not make inheritable gene edits. And that's what he did. By doing it in an early embryo, it meant it not only affected the children, but all of their children and all their descendants, and thus the human race. And so the Chinese put him in jail for 3 years and banned him from ever doing research again, which I found encouraging, because if we're going to stop this technology, we have to do it hand in hand with the Chinese, who are a little bit ahead of us in this technology, and of course with the Europeans and governments around the world. So there's now an international group of scientists trying to say, let's put a pause for the moment on inheritable edits. Let's focus on what's medically necessary rather than enhancements. And let's see if we can do this cautiously. But by the way, I should say, let's not stop this. I mean, I get 20 emails a day now. I mean, I've just been looking at them that are heart-wrenching. Or go to my Twitter feed and you'll see people saying, you talk about having to slow this technology down. Let me show you here's a picture of my 12-year-old granddaughter, and she has this rare genetic disease. Can you get me in touch with Jennifer Doudna? And I'll get, my 9-year-old son has muscular dystrophy. When can we fix it? So we don't want to slow this down. Like every creature large and small on this planet, we should use all the tricks we can to survive as a species.
You mentioned that photograph. The photographs in this book are excellent. And I know you've given attribution before, but you could do that again to the photographer who put everything together, because it's great.
Yeah, well, Crary Pullen was a photo editor, but Jennifer and every scientist I talk to, whenever I interview people, I say, give me your favorite photos of you at work, or, like that. And what I want to give real attribution to Simon & Schuster, which has been, as you say, the beautiful publisher. They do wonderful books. I've been with them for 30 years or so, never been to another publisher, because when I asked them, let's have color pictures, and lots of color pictures throughout the book, not just in one of those little insert sections that you have to go look and find. But every time I say something like George Church is a great scientist at Harvard, he looks like a woolly mammoth, I want a full page color picture of George Church right there. When I talk about Feng Zhang, the other person racing against Jennifer to do this, saying he's from China but grew up in Iowa and has a corn-fed cheeriness, there's a smiling picture of him. And so Simon & Schuster was able to make the book so that the color pictures throughout, and partly, I guess, because I've been around and loyal enough, and I said, and I want it to be the exact same price as any other nonfiction book. I don't want to charge the reader more. So I want it to be beautiful, because as we talked about at the very beginning, nature is beautiful. It's important to appreciate beauty.
Yeah.
Steve Jobs loved beauty, which is why he made the iPod and the iPhone so beautiful. And I wanted this book not only to be a nice narrative people could read, or an adventure story about science, but also to be a beautiful book with color pictures throughout.
You tell that story in Steve Jobs' book about how his father did the back of the furniture maker, and he did the back the same as the front. And Steve Jobs said, no one will see it. Yeah. He goes, I'll see it. That's exactly what you're talking about.
The beauty of the parts unseen is something that Leonardo da Vinci understood, Steve Jobs understood. And of course, Jennifer Doudna, in this book, understands the biggest questions there are in the universe, like how did life begin? And she actually tackles them and helps solve them. But she also knows that God is in the details, and that beauty is in the details, and how the particular piece of RNA folds and how it twists and how it shapes. That's the key in the detective story of saying, what can a molecule do? And we learn that with the spike protein of the coronavirus. You have to understand, and in some ways, there's a frightening beauty. If you truly see a picture of that spike protein in high resolution and how it folds, it's frightening, but it also is the key to solving the mystery of how we're going to stop it.
That's a great way to start really quickly, because it's a very important part of the book about women as scientists. Mm-hmm. And when Jennifer first saw that Double Helix book, she wasn't going to read it because she thought it was a detective story, a mystery. And then you can take us forward to the Watson-Rosalind Franklin situation.
Well, she read the book when she was in middle school because her dad left it on her bed. Her dad knew that she had a curiosity about nature, and every now and then would just leave a book on her bed for when she came home. And when she finally got around to reading it on a, rainy Saturday, she discovered it was indeed a detective story, but a detective story about the secrets of life and what are the clues to understand how life works. And one of the characters in the book was named Rosalind Franklin, a great woman biologist who was able to do images of DNA to show how it twisted and folded. And it was those images that helped James Watson and Francis Crick discover the structure of DNA. Now, she's treated rather condescendingly in that book, but Jennifer told me I didn't even care about that. What I cared about was that women could be scientists. I'd never thought about that. So I told my school counselor, I want to be a scientist, she said. And she was growing up in Ilo, Hawaii, a small town on the Big Island. And the counselor said, no, girls don't do science. But she persisted, and she became somebody who realized the beauty of little molecules, and they're simple. It's not like doing Einstein's relativity. These are very simple molecules with a four-letter code and twists and turns, and she makes all these great discoveries about them.
What's interesting is you never cut any corners in your books. And when you and Jennifer, I believe, went to see Watson, I guess he's in his 90s. He's still around. He's in his 90s now, right?
Right.
And I think Jennifer thought maybe, and you too, might be a case of redemption. But then she says in your book, it didn't turn out exactly the way she thought. And you don't cut corners there.
Well, it's a difficult thing to approach. Especially, we're all sensitive to everything that might have to do with everything from anti-Semitism to race or whatever. But Jim Watson was a genius. He did help figure out the structure of DNA, but then he went to the dark side. He believed everything is genetically determined, which it is not. And it's partly because he has a son who's in the book, Rufus, who's schizophrenic. And James Watson believed that the schizophrenia was totally genetically caused, that he would be able to someday find out the genes that caused it and maybe fix it. But schizophrenia, like most of our traits, is a very complex mixture of genetics and environment and chance and mysterious things we don't understand, like maybe free will, which I certainly don't understand. But James Watson became fixated that IQ and personality should be seen only or mainly through a genetic lens, through DNA. And that leads him to areas, you don't want to go, including about different ethnic groups and other things that are just not scientifically accepted or valid. And so he's been a pariah now. But because the book starts with his double helix, and because Jennifer and I were at Cold Spring Harbor Lab on Long Island at a CRISPR conference and doing work on CRISPR, and even though he's been banished from those meetings, he still has a house on Cold Spring Harbor Lab grounds. And I decided we should walk up and talk to him. And you'll have to read the book, but as you said, it's disappointing.
I know. I felt bad about that. I thought as you went through it, I thought, okay, he's going to come to some type of epiphany. And Jennifer says, no, it didn't happen. Not in a mean way.
90s. I mean, and the complex thing, whether it's with DNA saying, okay, all these traits are intertwined, and even the trait that might give you sickle cell might protect you from malaria or West Nile disease. All these weird things are intertwined. We have to figure out the complex intertwining of genetic, determinants, like for blue eyes, genetic dispositions that might predispose us to be a certain way, but not cause us to be a certain way, and how those might be the predispositions that cause them to be a passionate scientists that discovered the structure of DNA might also have led him to not be as open-minded about the moral consequences.
Yeah, and that brings me to something that you acknowledge, but it's not as okay. It's like in Leonardo, when you talk about, which we could talk about all day, Leonardo and Michelangelo and their feud, but there's also the same similar type of situation here in terms of the race to the finish. Talk a little bit about that and the patent fights and things like that.
Well, Jennifer Doudna, with her partner, research partner, Emmanuel Charpentier, in 2012, took this weird system that bacteria have to fight viruses. It's a system known as CRISPR. And simply put, it's clustered repeated sequences known as CRISPRs that are in the DNA of bacteria. And what they do is they store a little mugshot, a little snippet of any virus that attacks them. And then if that virus attacks again, they have a little bit of a guide that uses a scissors to chop it up. And that's kind of what we need in this day and age where we keep getting hit by variants of viruses. So bacteria do that. And Jennifer Doudna and Emmanuel Charpentier in 2012 figure out exactly how the system works. And it's real simple. They engineer it so that it only has two components, a guide RNA and an enzyme that acts as a scissors, and it can cut DNA wherever you want.
And you even learned how to do it.
And I did it in a lab with her, figured out how you use it. And when they do that, they have an aha moment, which is we could reprogram it so that the guide doesn't cut, a virus DNA or RNA. It cuts our own DNA. We can make it into a tool that edits our genes. Now, a lot of other scientists were working on gene editing, and they win the Nobel Prize just recently for that paper in 2012, saying, here's how it works, here's how it can be used as a gene editing tool. But they get into a race, especially with a guy named Fung Lu, a wonderful guy from the Broad Institute of MIT and Harvard, to say, let's use it in human cells. Because when they had done it in test tubes using bacteria cells. And the term of law is called obviousness. Was it obvious it would work in human cells? That's still being fought in the patent courts. But Fung Lu beats them by 2 weeks in showing how it can be optimized to be used in a human cell. And so there's still a patent battle over who should have all the patents. They all have patents now, but they all conflict on using this as a human gene editing tool. But the good thing is they put aside all these patent battles when they turn their attention to fighting COVID.
Yeah, and you liked Fung. I mean, you said his personality was very pleasant to you.
When I went to see him, and I'm one of those old-fashioned reporters, like if I'm going to do this book, I'm going to go hang out with people in their lab. It's the only way to really get them to talk. I called him and emailed him or whatever, and asked if I could spend time with him in his lab. And I was a little worried because he's in this big race and competition and rivalry and patent battle with Jennifer Doudna. And Jennifer is the main character in my book. But he was about as gracious as you can be. He had immigrated as a young kid with his mom to Iowa, and he sort of was imbued with that corn-fed hospitality and graciousness and decency of the Midwest. And so it's like, yes, come to my lab, come hang out. Let's go eat illegal seafood in Kendall Square in Cambridge together. And we even had a wonderful dinner in Quebec at one point. We were both going there for some CRISPR work. So he's a great guy. And one of the things that, disappoints me a bit, I would love to have been able to get him and Jennifer together in a room with a nice glass of wine and let them just shake hands and say, let's cross-license our patent. We don't have to be this competitive.
Yeah, I know.
But, competition's a good thing.
Yep.
Competition spurs science on. It spurs journalism. It spurs, business on. So I like competition. And when people say, well, Jennifer's rather competitive, I go, yeah, isn't that great? So I like the fact that they're competitive.
And I'm glad you're getting back to the science on each of my questions, because my questions seem to be a little gossipy, which leads to Emmanuel Charpentier. And I know you're fluent in French and you use that word charmant, which you say you don't really know what it means, but maybe you could tell, because she does get a little bit of short shrift. So maybe you could tell the reticence and.
Well, I said I didn't know what charmant meant fully until I met Emmanuel Charpentier, because then I said, I get it. So that's what charmant is, because she's charming, totally charming, mesmerizing, deeply gazes into your eyes, invites me to her lab in Vienna. We have long, dinners together at Japanese restaurants in Berlin. But there's a certain aloofness, an amused aloofness to her. And so even though she bonds scientifically with Jennifer Doudna, the main character of the book, and even though they become friends, referring to each other by nicknames, Jennifer calls Emmanuel Manu. After they make their discoveries, they drift apart a bit because Emmanuel's a bit of a loner. She moves from lab to lab. She started in Paris, went to New York, went to Memphis, went to Berlin, went to Umeå, Sweden is now, and went to Vienna. So whereas Jennifer makes some tight, close relationships. And so that was sort of an odd, like two molecules bonding. It was an odd bonding experience with them because they do have different personalities, but that diversity of personalities is important.
Yeah. Oh, you know what I wanted to ask you before we close out is your dedication to those two lovely women. Mm-hmm. And maybe you could just amplify on that a bit.
These are two women at Simon & Schuster who've been there almost my whole career, especially Alice, who has definitely been there my entire career. Alice Mayhew, for the 40 years since I, first came out of college and started wanting to write books, has been my mentor and editor. A friend of mine and I, in the early 80s, went by her house one day and said, we want to write about 6 friends who helped form the Cold War. And she published that first book of ours, The Wise Men. And ever since then, all my books, as I've said, have been with Simon & Schuster because both the quality of their beauties of their books are great, but because Alice and now Priscilla Paynton, her successor, have been great editors. But Alice, when I went to see her 4 or 5 years ago or have lunch with her, I had done Ben Franklin and Leonardo and Steve Jobs and Einstein. I said, now I want to do an unknown woman scientist with a name most people can't pronounce, who's working in a field with an acronym people don't know what it stands for. And I thought she'd say, well, you're out of your mind. Why don't you do Isaac Newton or something? And instead she said, that's a great idea. It's a journey of discovery, and people love journeys of discovery. And she had edited 40 years earlier, in 1979, the classic of that genre, Horace Freeland Judson's The Eighth Day of Creation. And so she said, make it personal, go hand in hand with Jennifer. Don't make it at all a science textbook. Make it an exciting page-turning narrative of a very interesting woman and all of her colleagues, friends, and rivals as they race to help the human species. And so I gave her the book in December of 2019, the first half of the book, and she came back with a torrent of wonderful suggestions, but then she died. And her mentor at Simon & Schuster, Carolyn Reedy, also died. She was CEO of Simon & Schuster. And they both had the biggest smiles, 1,000-watt smiles. And if you ever saw their smiles, you'd want to make them smile. And so every sentence I wrote in this book, I asked myself, is this a sentence that would make Alice smile? Is this a sentence that would make Carolyn Reedy smile?
That's lovely. And again, going back to my bookstore mentality and what you're saying about Simon & Schuster, I love the fact that I get books sometimes and the covers are fanned out and the text block is not clean. But it's so nice getting your books, because even when I stack, we got some new ones yesterday, and when I stack them up, they're all so clean and the text block is so perfect. And you did pick the right people. There's no question about it in my mind.
I could go through a list, but I ask people to look at the acknowledgments of all the art. People say, why do you publish books with, big publishers now? Whatever. You go through 20 people there, from the art directors and the design directors and the photo editors like Crary Pullen, and the copy readers and people do it. It takes 20 or 30 people to make a book right. And we get our name on the cover, but it's a publishing house that makes it perfect.
Well, let me ask you this in conclusion then. And it's a crystal ball kind of question, and it's a kind of painting you into a corner. But after we're gone, since we're exactly the same age, minus 24 hours, and this is, the best thing since sliced bread, what do you think? What do you honestly think in 30 or 50 years we're going to be able to do? And will that blurry line be crossed?
Yes, the line will be crossed. Already we've cured sickle cell, they've already done congenital, inherited blindness. In China, they're doing a lot on cancer, which is you can use this technology to help their, immunotherapies not get defeated by the cancer. Likewise, that's being done at the University of Pennsylvania. And we will do these single gene mutation diseases, muscular dystrophy, cystic fibrosis. That'll be a great boon to humankind. And pretty soon we'll be able to do things that are small enhancements, like make our blood or our memory slightly better. And that's where it's going to be good, really good, but we have to make sure that it's done equitably so that we don't allow rich people to buy better genes for their kids. And then we'll be able to edit out certain things we call disabilities, congenital deafness, let us say. But then we have to worry about what is a disability. In fact, is deafness a disability, or is it simply a differently abled trait? And does deafness add to the diversity of the human species? And that's a difficult moral issue that there's people wrestling with in my book, and I hope people who read the book find it interesting to have their minds open that way. And then the furthest frontier that won't happen for another 5 or 6 decades is there are things that predispose us to certain conditions, personalities, and traits. Height, of course, is pretty easy. Muscle mass is very easy. Hair color, eye color, skin color, that'll be pretty easy. Certain personalities, we will find genes that predispose for manic depressiveness, for bipolar disorder, for schizophrenia. I don't know that we'll find a simple set of genes, but we'll find a lot of genes that add to the predisposition to these conditions. That will also be a boon, but there will be a danger. We don't know the unintended consequences. If you edit the genes that cause schizophrenia in Rufus Watson, James Watson's son, and you had edited them a few generations before James Watson, would James Watson have been James Watson? Would he have, been both his good and his bad sides as pronounced? Would Hemingway have been Hemingway if he hadn't been depressive? There's a wonderful bioethicist in my book named David Sanchez, and he loves playing basketball. He's 17, except for when he doubles over in pain with sickle cell. And at one point they tell him, we may be able to edit your reproductive cells, in a few years, so your kids won't have sickle cell. And he went, that would be great. And then later he says, well, let me think, maybe that should be up to the kid after he's born or she's born. And they say, why? Well, sickle cell helped forge my character. It made me who I am. It made me empathetic. And I went, wow, that's interesting. You want to have your kids have sickle cell? He said, well, sickle cell is part of who I am. And then later I asked him, he said, no, I'd want to edit my children so they didn't have sickle cell. And I said, what about empathy? He said, well, I try to teach them empathy, but I don't want them to feel pain. So we have first thoughts, second thoughts, third thoughts about the things we can do. And that's what this book is about. It's not about giving you the answers, but giving you first thoughts and second thoughts and third thoughts. So we can go hand in hand down this slope make it less slippery, make it more morally secure as a society. We don't just leave it to the scientists or the politicians. It's up to you and me, us, all of us, to say, okay, I get what we can do, and let me be part of the conversation about what we should do.
Yes, it was like in your talk at Harvard Bookstore about the fact that deaf people do not consider, many of them do not consider their situation.
Thank you very much. Yeah, yeah.
Yeah, thank you so much
Talking
for
to you.
joining us today. And as I said, my bookstore, I'm happy, in part I'm happy, one, because your books do not end. You end asking questions. You end up being curious. And because of Google, you end up learning a lot more than you actually did in the book as well. So thanks so much, Walter, for joining us today.
Thank you for having me. It's a great pleasure. Bye-bye.
Bye-bye.
Great.